So today we start talking about vectors. Well, before we're going to talk about vectors, let's first introduce coordinate system. And we're going to have 2 points put in the space. We call point A, point B. Point A is going to have coordinates x, a, y, a. And point B is going to have coordinates x, b, y, b. Now what we're going to do, we're going to connect those 2 points with this straight line or segment, like this. And we're going to put an arrow at the point B. So it's a vector that goes from point A to point B. Okay? And we're simply going to define this vector, AB, via coordinates. And we're going to say coordinates are components of the vector, are coordinates of vector B, point B, minus coordinates of point A. So it means that it's xb minus xa, yb minus ya. Okay? Pretty simple and straightforward. So let's just look at one of the examples. Zoom in a little bit and shift it. Okay. So what we're going to do now, we're going to introduce again a coordinate system to the right of it. One, two, okay. And now let's say I have a point A which has coordinates 3, 3, minus 3, and 2. This is point A. Then I take point B which has coordinates 5 and minus 3. Okay. It's going to be here. So B coordinates 5 minus 3. A coordinates minus 3, 2. And now we're going to talk about the vector that connects these 2 points. The vector that goes like this. Vector AB. Coordinates of the end 5. Minus coordinates of the beginning minus 3, minus 3, minus 2. It means that AB is going to have coordinates 8 minus 6. Okay? That's easy. Now, let's look at the coordinates of the vector. So if you take our vector AB, again, let's change its name. Let's call it vector small c, and coordinates of vector small c is xc, yc. And if you're saying the c is AB, it means that the coordinates of c and AB have to coincide. So if you say c is AB, it means that xc will be xb minus xa, and yc will be yb minus ya. Okay? And now what I'm going to do is these formulas, I'm going to rearrange them in a different way. What I'm going to do, I'm going to say that xb is xa plus xc, and yb is ya plus yc. So what I did here is actually, I kind of reverse things a little bit. Before we're talking about the vector, coordinates of the vector through coordinates of the endpoints. Now I'm saying, what if I know coordinates of the vector, know coordinates of the A, beginning of the vector, and I want to find where the end of the vector is, okay? Everything clear? And now let's bring an example to clarify things even more, clarifying. So if I have a, again, let's say I have a vector 8 minus 6 as before. Let's say my AB was 8 minus 6. And I had a point minus 3, 2 as A. And I had point B at 5 minus 3. Okay. And I was saying I was connecting these 2 points and I was getting a vector AB. Well, let's call it vector C. Okay. I'm going to call it vector C. But now let's pick up another point. And let's pick up a point, let's say 3, 3. Okay. And it's going to be point, let's call it A prime. It's my new point, 3, 3. And that's where I'm going to start my vector. And I'm saying, well, what if I use the same vector C, but I'm going to start from point A prime? So what do I need to do to find the end of this vector? Well, since the vector is 8 minus 6, what it means that we need to start at point A prime and then horizontally move by 8 points to the right. It's going to be somewhere here. Okay. I did plus 8 points. And then what I want to do, I want to move 6 points down because it says minus 6. Okay. I get a new point, and let me call this point B prime. Coordinates of this point are going to be 3 plus 8, which is 11, and vertical coordinate will be 3 minus 6, means minus 3. Okay. Now, if I connect points A prime and B prime with a vector, as before, and I look at coordinates of this vector, I'm also going to get coordinates of vector C. Okay, so this vector is going to be again 8 minus 6. Okay. And what happens is really I can pick up any point A, beginning of the vector. Then I'm going to move 8 points to the right and 6 points down. And I'm going to get a new point. And when I connect these 2 points, I'm going to get vector C. Okay. So really coordinates of the vector tells you that really we can put a vector wherever we want. The way we define the vector could start wherever it wants. Okay. And what we have to do after that, we just start at point, move certain number of points horizontally, certain number of points vertically, and we get an end point. And we can create multiple vectors like this from the same, and every time we're going to have this vector C. Okay. And what we also find that those vector C's we're going to get, all these vectors are going to be parallel to each other. Okay. They're going to be pointing in the same direction, and they're going to have the same length. Okay. So that brings us to another point, and the point is what is the length of a vector? And the way we're going to define the length of a vector is really as a difference. It's between point A and point B from the beginning till the end. So really it's the length of a segment AB. It's the same for a vector. So really if my coordinates are xa, ya and xb, yb, in this case a length of vector A, which I'm going to show right as use symbols of absolute value of AB, and also say it's a C, is the coordinates of xb minus xa squared plus yb minus ya squared. Okay? And the square root of that. Okay? And also it means that the I'm going to use the coordinates of the vector c, is going to be x coordinate of vector c squared plus y coordinate of vector c squared. Okay? So, and if you look at our example, in our example, when vector c is 8 minus 6, the length of vector c is square root of 8 squared plus minus 6 squared, which is 64 plus 36. We get square root of 100, which is 10, right? So that's pretty easy. Okay. The last thing I want to say, we can move our vector wherever we want in a parallel fashion, and it's still going to be the same vector with the same coordinates. Okay. So one vector that kind of very interesting for us, and that's the vector that has a beginning of it, point A, at the origin of coordinate system. Okay. So what happened in this case? If I take a coordinate system, again, okay, this is my coordinate system, and I put the beginning of the vector at an origin. In this case, the coordinate, if I draw my vector this way, and this is vector, well, let's call it D, is coordinates x, d, y, d. Okay. In this case, coordinate of the end of the vector going to be x, d, y, d. So if this is my A at point 0, 0, B going to be at the point x, d, y, d. So what we find that the coordinates of the vector and coordinates of the end point are actually the same. Okay? And this is happening when the beginning of the vector is at the origin of coordinate system. Okay? So here I want to make a small comment that although when we look at the coordinates of the point B and the vector D, we see the same thing, okay? Those things are not the same because the vector has a length, has a direction. The point does not have either, okay? The point also is fixed in space. In the vector we can move, okay? So again, it's just a problem, I guess, with notations, and we just reuse notation for vector as the same notation as for the point. So, but really, in general, those are not the same things. And normally, when we're gonna put the coordinates, we're gonna clarify whether we're talking about coordinates of the point or coordinates of the vector. All right. See you in the next video.